So we talked about Sharpe ratio in the last lecture. It is a reward to risk measure. Right? So the numerator is a reward. So it's the average return on the portfolio P minus the average risk-free rate, or you could just call this as excess portfolio return or excess return on the portfolio. And then this is the volatility or standard deviation of the portfolio's return. Remember that you guys learned in corporate finance 2, that is, volatility is the same as standard deviation. And today let's talk about M-squared measure. And I mentioned in the last class, it is called M-squared measure because it is popularized by two Lianis. So the idea of M-squared measure is like this. Let's say you wanted to measure portfolio P's performance. Then you will want to mix this portfolio P with T-bills. Here T-bills T-bill is a typical risk-free asset, right? And then I call this mixed portfolio as portfolio P star. And then I will think about how much I want to allocate into portfolio P and how much money I want to allocate into T-bills. So by correctly allocating my investment between portfolio P and T-bills, I can make sure that this mixed portfolio P star has the same volatility as the market index. Right? Again, to think about market index, if you're in the US, you could use SP 500, and if you're in Canada, you could use the TSX Composite Index. And then by making sure P star and the market have the same volatility, now I can compare their returns, right? The return difference between the P star and the market is called the M-squared measure, right? So you can say that the idea of M-squared measure is you want to control the volatility of your portfolio. So how do you control it? Well, you mix it with some T-bills. Okay, so let's see how this works. Let's say you have a portfolio P and the market portfolio is here. And then the horizontal axis gives you the volatility or standard deviation. The vertical axis gives you the expected returns. And then one way, right, given expected return and volatility, one way to do the performance measure is to just calculate the Sharpe ratio, right? So here the F is the risk-free rate. Now, if you wanted to use Sharpe ratio, you can see that the Sharpe ratio of portfolio P is given by the slope of this curve, right? Because what is Sharpe ratio? Sharpe ratio is expected return of portfolio P minus our F divided by its standard deviation. You can see that this is the rise, which is expected return of portfolio P minus RF. And this is portfolio P's standard deviation, right? So by the same token, you can see that the Sharpe ratio of the market index is again given by this line is given by the slope of this CML line. Right? So this is the Sharpe ratio of market index. And then you have these two lines, right? How do you get these two lines? How do you get this CML line? Well, what you do is you are just basically connecting the risk-free asset and the market portfolio. And this is called capital market line. And you guys have learned about this in corporate finance too, right? And then this CAL is the capital allocation line. So it's the line connecting the risk-free rate and the risky portfolio P. And now let's see how do you find out this M squared measure. So what you do is you will want to construct this P star here, right? So you can see that this P star is constructed by mixing this risk-free rate and this portfolio P, right? Because P star is on the line connecting risk-free rate F and portfolio P, right? So you can see that by mixing P and the risk-free investment, we have a portfolio P whose volatility is the same as the market portfolio. And then you can see that the difference between the return of the market index and the return of the P star gives you the M squared measure, right? So it's this distance here. Okay, let's see a example. Let's say portfolio P has an average return of 35% and its volatility is 42%, and the market index has an average return of 28% and a volatility of 30%. So calculate P's M squared measure. Obviously, the first step is you want to find out this P star, right? To get P star, you have to mix a T-bill with portfolio P. So let's assume, right, portfolio weight on P is given by X. Right? Portfolio weight has been discussed in corporate finance. Essentially, it is the percentage of investment you put into portfolio P. Right? For example, if you have a total investment $100 and you invest $10 into portfolio P, then the portfolio weight of P would be 10 divided by 100, which is 10%. And then in this case, P star's standard deviation is X times standard deviation of RP. Right? So SD, right? That is the standard deviation of the portfolio P star's return equals X times the standard deviation of portfolio P. Again, this comes from the first lecture of Corporate Finance 2. So if you cannot remember this, well, go back to your Corporate Finance 2 lecture note. Okay, now let's solve X. We know that the standard deviation of RP is given by 42%. And we want to make sure our P star's standard deviation to be the same as the market index. So we should have 30% here. This implies X equals to 30% divided by 42%, which is what? So it's 0.714. And now we could calculate portfolio P star's return. Right? So it's the portfolio weight of P times portfolio P's return. So it's 35%. And then the portfolio weight of the T-bill times the risk-free rate. What is the risk-free rate? Let me see. I think something is missing here. Oh, we have the 6% risk-free rate. So we actually need this additional number. So risk-free rate is 6%. So this gives us a number of 26.7%. And then we can find out this M squared measure is our P star minus the return of the market. So 26.7% minus 28%, which is 1.3%. So you can see that this portfolio P is underperforming the market, right? Note that here, it's very important when you're doing performance evaluation, if you just want to compare returns, you have to adjust its volatility, right? What you see here is if you fail to adjust volatility, then you can see that just by raw returns, right? You can see that portfolio P actually has a higher return compared with the market. So it seems that your portfolio is outperforming the market, but in fact it is not, because you're getting higher return because you're bearing higher risk, right? So you have to make sure P has the same risk as the market index. Then by comparing return, then you can say whether you're outperforming or underperforming the market. This seems trivial, but in real life, if you think about how most retail investors talking about their returns, it's like almost every time they would never adjust their standard deviation. Well, I guess 90% of them don't understand their returns volatility. So there's no way for them to know how to make this adjustment, right? So, the takeaway here is raw return is not a good measure of performance. You have to consider risk. So M squared is a simple way to adjust risk, and then after adjusting the risk, you can use the adjusted return as a performance measure. Okay, now Jensen's alpha. So this is really not a performance measure. However, several performance measures are based on Jensen's alpha. It's called Jensen's alpha because this procedure is proposed by Michael Jensen, this very famous financial economist. So alpha is the difference between your portfolio's return and the return predicted by CAPM, capital asset pricing model. Oops. So you can see that here this R bar P is the average return on the portfolio P. And this is the return predicted by capital asset pricing model. If you want to know exactly how this works, you have to learn econometrics. You have to understand how linear regression works. And because econometrics is not a prerequisite for this textbook, so I'm not gonna talk about how exactly linear regression works. The key here is I only require you to understand this concept, not about the exact econometric methodology. Okay. So essentially you can see that conceptually, right, alpha is just the difference between the actual return and the return predicted by model, right? Here the model is the capital asset pricing model. And you can see that if alpha P is positive, now you can see that this is, in some sense, it's a good investment, right? Because you're getting positive alpha. Essentially, it means that your return is higher than return predicted by model. Right? Okay, so now the third kind of measure, Treynor ratio. So the definition is, you can see that the construct of this measure is somewhat similar to Sharpe ratio, right? So what you do is you will find out the excess return, right? So the average return of your portfolio minus risk-free rate divided by beta of your portfolio, right? So you can see that the trade-off ratio is similar to Sharpe ratio because Sharpe ratio is using the same numerator. The difference is Sharpe ratio is using sigma p, right? It is using the volatility of your portfolio P's return. But trade-off ratio uses beta. So you can see that the difference between these two ratios is really about how you think about risk, right? If you care about the total risk, then you will look at Sharpe ratio because sigma p, that is volatility, is a measure of total risk. Remember we learned about total risk in corporate finance too. Well, unfortunately, I have to go back to corporate finance too. So if you have not taken corporate finance too, maybe it's better for you to borrow a book, right? Read related chapters. Because sigma p, which is the volatility, it is a measure of both systematic risk and non-systematic risk, right? And then beta p, it is just a measure of systematic risk. So if you just care about systematic risk, then you should use trade-off ratio. But if you care about both systematic risk and non-systematic risk, then you should use Sharpe ratio, right? Now you might wonder, hey, when should I care about both risks? That is, when should I care about both systematic and non-systematic risk? When should I only care about systematic risk? Well, it really depends on what you're trying to do here, right? So let's say you have $10,000 and you will put this $10,000 into a single portfolio, or you're building a large portfolio and you will use all your money to build this large portfolio. Now you should think about, or now you should use Sharpe ratio because you're looking at your large single portfolio. In this case, there is no additional assets to generate this diversification effect. So what matters to you is the total risk, which is measured by volatility. Now, let's say you're in a different scenario. You have $10,000 and you have all these little investments, right? So now you try to allocate $100 into this portfolio A. In this case, you should use trade-off ratio. The reason is portfolio A is just a component. It's just a small part of your total investment portfolio. So portfolio A so the non-systematic risk of portfolio A can be diversified by all these other portfolios. So non-systematic risk does not matter, right? So in this case, you will use its systematic risk as a risk measure. So you will use trade-off ratio. So basically, to summarize, if you're looking at a single large portfolio, you're trying to evaluate it, and that's the only portfolio you want to invest in, then you should use Sharpe ratio. And if you're looking at a component or a potential component of a larger investment portfolio, then you should use trade-off ratio. Okay, next, the final one, information ratio. So the information ratio is defined by the alpha divided by the diversifiable risk. So here, H refers to portfolio H. And alpha H is portfolio H's alpha. Obviously, alpha is defined by this little equation here, Jensen's alpha. And then sigma h refers to standard deviation, right? And EH refers to non-systematic risk. So this, right, this denominator measures non-systematic risk. Again, to get a better understanding how this works, we need to talk about the portfolio optimization, and we have not talked about this yet. And here, the requirement is, if I give you a number of alpha, and if I give you a number of this non-systematic measure, then you should be able to figure out the ratio of these two numbers, means information ratio. Now, why do we care about information ratio? Well, the reason is because information ratio tells you the incremental improvement of your Sharpe ratio if you have additional investment. So let's see how this works. Let's say you have a market index fund M, right? For example, you have invested in SP 500, and then you decide to add another fund, H. And you can see that originally, right, you have SP 500. And now adding fund H, you will have a larger portfolio. So let's call this portfolio as portfolio P. And then the portfolio P's Sharpe ratio is given by this formula. Well, what you can see here, right, you can see that the improvement in the Sharpe ratio is given by the information ratio, right? So you can see that if this fund H, this guy, has a larger information ratio, then portfolio P Sharpe ratio will be larger, right? Okay, let's compare these several performance measures. First, Sharpe ratio. It's defined by excess return divided by standard deviation. And then Treynor ratio. It's defined by excess return divided by beta. Information ratio, alpha divided by the residual standard deviation. Now, when do you want to use these ratios? Well, when you're looking at your overall risky portfolio, that is, you have a single portfolio and you try to evaluate it. In this case, you will use Sharpe ratio. And then you're just looking at a component. If you're looking at a component which will be mixed with other investments to form a larger portfolio, in this case, you should use Treynor ratio. Right? And then if you're evaluating a portfolio which will be mixed with an index portfolio, in this case, you should use information ratio. Okay, now let's look at this example here. So let's say we have portfolios P and Q, and we have these three measures: Sharpe ratio, M squared, Treynor ratio, and information ratio. Which fund would you choose if you were investing all your money in a single portfolio? You can see that, well, if you invest all your money in a single portfolio, then the total risk of this single portfolio matters, right? So you should use Sharpe ratio. Right? So you should use Sharpe ratio. And you can see that if you use Sharpe ratio, which portfolio should you choose? Well, you should choose portfolio Q. Or you could use M squared measure. Again, it will tell you should choose portfolio Q. I mean, if you use Sharpe ratio, and if you use M squared ratio, you will always get the same result. The reason is because M squared measure is just a different form of Sharpe ratio. Which fund would you choose if you were considering adding P or Q to a larger portfolio? So you can see that in this case, portfolio P and Q are both components of a larger portfolio. So if P and Q are just components, then their non-systematic risks are not important because it can be diversified away. In this case, you should look at its systematic risk. So you should use trade-NOR ratio. Right? So you should use trade-NOR ratio. And then you will again choose portfolio Q here. Which fund would you choose if you were considering adding P or Q to market index portfolio? So you can see that here you should use information ratio, because information ratio tells you what kind of improvement you can get in terms of Sharpe ratio when you're adding a portfolio P or Q to your market index fund. Right? So in this case, you should choose P. Right? So you can see that it's actually important to understand the usage of these different portfolios. Then according to your specific scenario, then you should choose the correct performance measure. Okay. Now last, let's talk about alpha. You can see that we defined alpha, but then it seems that the only use of alpha is about information ratio, right? So we only used alpha to define information ratio. It seems that alpha is not that important, but actually alpha is quite important. If you talk about industry people, right? People from hedge fund, from investment management firms, then they're a major job of their, or a major part of their job is to looking for alpha. So alpha has a central role in investment management. So here, let's see how alpha is related to different performance measures, and then you will understand why alpha is so important. So let's say we look at trade-NOR ratio, right? It seems that trade-NOR ratio is just defined by this, and it seems that it is not related to alpha. However, we know that. So what is alpha? Well, alpha P equals RP minus RF plus beta P times expected market return minus RF. Again, this is just by using capital asset pricing model. So what you can see here is ERP minus RF can be written as alpha P plus RF plus beta P ERM minus RF divided by beta P, which would give you alpha P plus beta P ERM minus RF divided by beta P. And then this will give you alpha P beta P plus ERM minus RF, right? Okay. So you can see that, right? You can see that how these different components are related. And this ERM minus RF can be written as ERM minus RF divided by 1. Right? So what you can see here is this is the trade-NOR ratio of portfolio P. And this is the trade-NOR ratio of the market index. So why this one is the trade-NOR ratio for the market index? Well, because for a market index, its beta is always 1, right? So what you can see here is the trade-NOR ratio of portfolio P and the trade-NOR ratio of the market index. They're related To be more specific, the training ratio of portfolio P minus the training ratio of market equals alpha P divided by beta P. So this basically tells you that if you have a larger alpha, then the improvement from your portfolio compared with the market index is larger, right? Now you could actually do the same thing with Sharpe ratio, but to save some time, I will not give you the proof. So if you're interested, you can do the proof to show that these results actually hold. By the way, this part is essentially a simple proof here, and it is definitely not required. Okay. So what you can see here is the Sharpe ratio and the Sharpe ratio and the market, they're related, right? So again, you can see that if you have a larger alpha on your portfolio P, then the improvement in your portfolio P's Sharpe ratio will be larger, right? And then we could also see an interesting result. That is, if portfolio P's alpha is positive, then it always increases training ratio, right? That is, if alpha P is larger than 0, then this will be larger than 0. So TP will be always larger than TM. However, you can see that positive alpha can actually reduce Sharpe ratio compared with the market, right? So if, let's say, if alpha P is larger than 0, but sigma P is very large, then you can see that the right-hand side could be potentially negative. This implies SP is larger than SM. Right? So this tells you that even if you have positive alpha from your portfolio P, however, if the non-systematic risk of your portfolio P is too large, your Sharpe ratio will actually suffer. It will actually be lower compared with the market index. Right? So alpha is not everything. You have to think about the cost of alpha, right? Whenever you're adding alpha into your portfolio, you're also adding some additional risks into your portfolio. So this is the trade-off here. And you have to think about the trade-off between alpha and this non-systematic risk. Okay, now we talk about style analysis. So this is a different way of thinking about performance evaluation, and this is a method proposed by Sharpe in his famous 1992 paper. The idea is you want to understand how a particular fund is exposed to different styles. So what is a style, right? Well, style basically means your style of investment. Let's say if you tell some people, hey, I like to invest in large cap stocks, then this is your style, right? So your style is to invest in large cap stocks. If you tell, or if another person says, hey, I like to invest in high growth firms, this is also a style. So it means that you have the style of investing in high growth firms. Or you could say, hey, I like to invest in tech firms. Again, your style is about investing in tech firms, right? So style analysis is used to understand a portfolio's exposure to different styles, right? This again requires econometrics. So I will just talk about the methodology. Obviously, in the exam, I will not ask you to actually do the analysis. You just need to understand the basic concept. That is, I will not ask you to use linear regression, right, to solve these different components. Okay, let's see how this works, at least conceptual. So let's say you have a portfolio I, right? And its return is denoted by Ri. And then you have n different style portfolios, right? So you have F1, F2, Fn. These are returns of your style portfolios. For example, this F1 could refer to return of large cap, right? So this is one style. Then this could refer to return of value firms. So this is a second style. You're investing in value firms. And this nth style could be return of, let's say, return of tech firms. So again, this is a different style. So you can see that what you're trying to do is you're trying to decompose this portfolio I's return into different components. Conceptually, there are two major components here. This is the first component. And what you're trying to do is the first component is about your exposure to these different style portfolios. And then you have this second component, EI here. So EI is really the regression residual. And this residual is also called tracking error. So this measures your ability of security selection and market timing. By the way, what is security selection? This is easy, right? It basically means, let's say the US market has about, let's say, 5,000 different stocks. And your portfolio has 15. So this basically means you have selected 15 stocks among 5,000, right? So this is about security selection. And if your 15 stock portfolio can outperform the market, then I could say you as the investor have superior ability of security selection. Now, what is market timing? Well, this is really about rotation. So market timing refers to this. So let's say I have $1,000. I have $1,000. And I have two kinds of investment, SP 500 and T-bills, right? So let's say I'm doing the following thing. So this is January. This is February. This is March. So let's say at the beginning of January, I predict the market will increase. So I will do 100% in SP 500. And then I predict in February, right? The market will continue to increase. So again, 100% SP 500. And then I predict in March, the market will drop. So I will exit. And then I will put 100% in T-bill, right? And next, I predict in April. I'm not so sure. So I think potentially it will decrease or it will increase. So I will put 50% in the SP 500 and 50% into T-bill. So this is called market timing. You're a market timer. So you're trying to time the market by correctly predict entry and exit, right? So essentially you can see that this style analysis is really a decomposition, right? You decompose the return of portfolio I into two components. The first component is about the returns of these style portfolios. The second component, which is represented by EI, is the return from your ability of security selection and the market timing. And then Sharpe requires some additional constraint. So he requires that the coefficient between these style portfolios, they should have a sum of 1. That is, this B, that is, this BI1, BI2, and BIN, their sum should be equal to 1. Right? And then we can also define R squared. So if you have learned econometrics, then it's very easy to understand what is a R squared. But if you have not, so I have this definition here for you. So how do you define R squared? So you're using the variance of this EI divided by the variance of this RI. And then you would use 1 minus this ratio. So the meaning of this ratio is it measures the return variability due to style portfolios. Or you could say the variability of, or the change of RI, or the portion of change of RI, which is explained by these style portfolios. Right? Okay, I understand this part looks complicated because, again, you need some understanding in econometrics to understand this part. Okay, so let's look at this example here. So now we looking at a fidelity fund, right? So it's a mutual fund. So we try to do some style analysis on this mutual fund. What we do is you can see that here we have these style portfolios, right? So we have T-bill, small cap, medium cap, large cap, growth, medium PE, low PE value, right? So we have 7 different style portfolios. And then we will actually use linear regression to regress the return of this mutual fund on the return of these 7 style portfolios. And we will get these regression coefficients. So what we have here is you can see that the coefficient on the large cap is the largest. Right? It's like 61%. And the medium cap is the second largest, 35. And for this high PE growth stock style portfolio, it's 5%. So I can see that this Fidelity Mutual Fund has the largest exposure to large cap, right? And then it has the second largest exposure to medium cap. And it has some small exposure to growth stocks. And then if you look at this number, 97.5, it means that the regression can explain the regression can explain 97.5% of the variability in this Fidelity Fund's return. Right? Okay. Okay, so I talk about this, that is, by the regression, the large cap stocks, medium cap stocks, and high PE growth stocks, they can explain 97.5% of the variance of the Fidelity Fund's return. And then you can see that there is also this residual percentage, 2.5%. So 2.5% of this Fidelity Fund return is explained by security selection and market timing. And then, which is not, so there's a number which is not listed in this table. That is, the average residual was 32 basis points per month. So if you look at this. Essentially, it means that the outperformance of this fidelity found compared with these style portfolios is 0.32% per month. And you can see that if you calculate the cumulative abnormal return, then the 5-period return is 19.19%. So you can do this using, so we have what? We have 5 years, 60. Right? I suppose this is the number you can get. Okay. Okay, I will skip this. Okay, now let's talk about a interesting topic, which is the performance measure with changing portfolio composition. So previously we defined several performance measures. The implicit or the caveat for using those performance measures is they are more accurate when you have a constant portfolio composition. But in reality, right, fund managers, they have the incentive and freedom to change their portfolio composition. And the performance measures can become complicated when managers change portfolio composition. So now let's start with a very simple example. So let's say the Sharpe ratio of the market is 0.4. Now we have a portfolio manager who will invest for 2 years. In the first year, the portfolio manager uses a low risk strategy. And then the returns every quarter are -1, 3, -1, and 3. And then the average return is actually 1%. Standard deviation is 2%. So you can see that Sharpe ratio is actually 1% divided by 2%, which is 0.5. So you can see that if we're using Sharpe ratio, the manager is outperforming the market in the first year. And then for the next year, the manager think a high-risk strategy is better. So the quarterly excess returns are given by -9, 27, -9, and 27. If you calculate using these 4 numbers, you can find out the average is 9% and the standard deviation is 18%. So here the Sharpe ratio is, again, 0.5. So basically you can see that using Sharpe ratio, if we separately calculate Sharpe ratios in these 2 years, then the manager is outperforming the market in these 2 years. Now let's calculate Sharpe ratio using or combining these 2 years. So basically now we have 2 years of return, or to be more specific, we have 8 quarterly returns. Right? Then if you do the calculation, right? So if you use these 8 numbers, right? These 8 numbers, and you can find out an average of 5% and 13.42%. Now, if you calculate the Sharpe ratio, right, 5% divided by 13.42%. Now you have a Sharpe ratio of only 0.37, right? So this is pretty interesting and weird, right? Because think about this. If you separately evaluate this manager in both years, this manager will have a Sharpe ratio of 0.5, outperforming the market, right? Then if you combine these 2 years data, and then you combine then you calculate a single Sharpe ratio, then the manager is underperforming the market. So which result is correct here? Well, actually, you should separately calculate the Sharpe ratio. That's the correct approach. Well, the reason is when you're using 8 quarters of return to calculate the Sharpe ratio, the change in the mean returns from the first year to the second year will artificially inflates volatility. Why? The reason is because, think about this, right? In the first year, the return was 1%. So this is the first year. And in the second year, the return would become, so what is the return? 9%. So there is a jump, right? So this is a jump. This jump will increase your volatility if you combine 2 years of data, right? However, you can see that this jump will not appear in your calculation if you separately calculate Sharpe ratios in year 1 and year 2, right? But should you include this jump in your calculation? You should not, right? Because this jump is really due to managers' different investment strategy, right? It's really because in the first year, the manager wanted a low risk strategy. And the second year, the manager preferred a high risk strategy, right? So the manager should not be penalized by this jump, right? Okay, so this basically tells us it's very important to understand how portfolios change in mean and risk. Then by understanding the reason for the change, then we could correctly evaluate the performance. Now let's talk about an interesting topic, which is about performance manipulation, right? So basically you can imagine that mutual fund managers, their compensation depends on their mutual fund performance, right? And you can see that they actually have the incentive to manipulate performance measures. So basically, if they could manipulate it, if they can get a higher evaluation, then they will get a higher salary, right? So let's see a very simple example here. So let's say a manager, right? So this manager is in the middle of a 2-leg evaluation period. Right? So let's say this is the evaluation period. And then this is the first leg. And this is the second leg. And the first leg has passed. So the manager is here, right? So he has already known his first leg Sharpe ratio, right? Now you can see that if this period has 2 legs, then it means that the overall Sharpe ratio will be some average of the Sharpe ratio in the first leg and the second leg. Right? So basically, here we will have Sharpe ratio 1 and Sharpe ratio 2. And then some sort of average will give us the overall Sharpe ratio. Right? So we will use some kind of average. Now, let's assume the first leg Sharpe ratio is very low. Right? That is, SR1 is very low. Now the manager standing in the middle of these 2 legs, he is thinking about the following question. Hey, what can I do to increase my overall Sharpe ratio, right? Well, obviously, if you want to increase your overall Sharpe ratio, then you have to increase this second leg Sharpe ratio, right? So how the manager can do this? Well, the manager will have the incentive to increase the leverage in the second leg. The reason is because, first, if the manager increases the leverage, then the influence of the second leg performance will be larger. And if the manager gets lucky in the second period, then the second period Sharpe ratio will be high. And because higher leverage increase the weight of the second leg Sharpe ratio, so this will increase the overall Sharpe ratio measure, right? Now, let's think about the opposite case. Let's say if the first period Sharpe ratio is very high. Now, what the manager wanted to do? Well, manager will think about this. Okay, the overall Sharpe ratio is a weighted average of the first leg Sharpe ratio and the second leg Sharpe ratio. Now I have already got high Sharpe ratio in the first period. Now I will want to reduce the weight of the second leg Sharpe ratio. But how could the fund manager reduce the weight of the second period Sharpe ratio? Well, what the manager can do is the manager will reduce the leverage in the second period, right? Because if the leverage in the second leg is lower, then the weight in the second leg will be lower. And then this basically means the weight of the first leg performance measure will be higher. So in the end, there's a higher probability this manager will be able to get a higher overall Sharpe ratio, right? And another reason for this is, just think about this. If you have already got a high Sharpe ratio in the first leg, then you will avoid taking risk. Potentially, you will want to invest in this risk-free asset in the second leg, because by going risk-free, you will completely preserve your first leg Sharpe ratio, right? So again, you can see that you will be underlevered if you have good performance measure in the first leg. Right? So basically, you can see that there is a negative correlation between the first leg performance and the second leg leverage, right? So if the first leg performance was bad, the manager will want to use larger leverage in the second leg in case he gets lucky, right? And then if the first leg performance was outstanding, the manager will have the incentive to reduce the leverage in the second leg, because he wants to preserve the first period superior performance, right? Now, how could we as investor to correctly evaluate managers if the managers can do some manipulation using different leverages? Well, there's a paper by these 4 people in 2007. They basically show that the Morningstar risk-adjusted return. So this is a performance measure developed by Morningstar. So this is a firm which rates different mutual funds, and it's actually a pretty famous mutual fund rating firm. So they find out that the Morningstar risk-adjusted return is the only performance measure which is impossible to manipulate, right? The requirement here is I only want you to know that there exists a measure which is called Morningstar risk-adjusted return, and it cannot be manipulated at least according to this 2007 paper. Clearly, you're not required to understand how can you exactly derive this result. Well, because you have to go back to their paper and see how they worked, how they derived to get this result. Okay, and they actually did some experiment. So what they did is they look at 100 different portfolios returns. And then they would plot Sharpe ratio against this Morningstar risk-adjusted return measure. They consider two cases, when there is no manipulation and when there is manipulation, right? So what they can see here is, the key here is you can see that you almost get a straight line here, right? So this basically means that Sharpe ratio is proportional to this Morningstar risk-adjusted return measure, right? So you can see that if there is no manipulation, if a fund has higher Sharpe ratio, it will have a higher Morningstar risk-adjusted return measure, right? And now if there is manipulation, right, what you can see here is the curve will roughly look like this. So it's a convex curve. The key difference are on the two sides. Here, 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 and here. So what you can see here is, let's say we just look at, right? Let's say we just look at these guys. What you can see here is their Sharpe ratio is roughly the same as the Sharpe ratio without manipulation, right? However, you can see that their Morningstar measure was actually much lower, right? Because here, without manipulation, the lowest Morningstar measure is about minus 0.3. But here, the lowest Morningstar measure is about minus 0.45, right? So you can see that there's some manipulation going on here, because on the surface, when you're using Sharpe ratio, these funds, they're not doing a worse job. But if you use this Morningstar measure, you can see that clearly they're doing a worse job, right? And now if you look at the right side of the picture here, now what you can see here is the Sharpe ratio with manipulation, right? The highest number is about 2.5, and its Morningstar measure is about 0.3, right? Now, if you look at this, with a Morningstar measure of 0.3, you don't have a fund with a Sharpe ratio of 2.5. So this basically means that these funds, they have the same Morningstar measure, but with manipulation, they can achieve higher Sharpe ratio, right? Because the highest Sharpe ratio here is about 1.8, right? And you can see that there is indeed some manipulation going on here. The reason is you can see this correlation between halves. This basically means you have the first half and you have the second half period, right? And you're looking at the correlation of returns between the first half and the second half. And you can see that if the first period was bad, then the second period will be better. And if the first period was good, then the second period will be bad. So there is this negative correlation here. You get a negative number here. Okay, to summarize, right? The key here is you're looking at these two sides. And on the left-hand side, you find out by keeping Sharpe ratio the same, the Morningstar measure under manipulation was worse, right? And on the right-hand side, by keeping the Morningstar measure the same, you can find out the Sharpe ratio under manipulation is actually higher, right? Okay, good. Now let's talk about market timing. I explained what is a market timing, right? In its really original form, market timing is about changing your investment between a market index fund and a safe asset, right? We talked about this example before. That is, if you have SP 500 and if you have T-bills, then depending on your prediction, right? If you think the market will increase, then you will invest in SP 500. If you predict the market will decrease, then you will exit and you will put your money into T-bills. So this is called market timing. And you can see, well, market timing is actually a very interesting topic. If you look at all kinds of YouTube ads and all kinds of crazy YouTube channels, people would tell you this kind of market timing strategy will earn you $1 million, something like this. And you can see that most of these online so-called experts, they're actually recommending strategies in market timing. But you will see that market timing is actually really hard. Of course, first you have to understand what is market timing. Now, how can we evaluate a manager's ability to time the market? So that's the question here. So the idea is like this. So let's say we think about a manager, right? This manager has a portfolio P. And this portfolio P has two components. The first one is the market index portfolio, such as SP 500. The second is T-bills. And then depending on this manager's prediction, the manager will shift the money between the market index portfolio and T-bills. Now, to evaluate this manager's ability to time the market, we will do the following. So what we will do is we will plot this manager's excess return against the market excess return. That is, on the horizontal axis, we will use the market return minus the risk-free rate, which is market excess return. And on the vertical axis, we will use RP minus RF, which is the manager's portfolio P's excess return. Now think about this, right? If the manager does not time the market, then the manager will always invest the same amount of money into the market portfolio. So let's say the manager does not time the market. Let's say the manager will put 0.6 or 60% of his money into the market portfolio and 40% into T-bills. And in this case, what is portfolio P's return? Well, portfolio P's excess return, right, would be equal to 60% of the market excess return, right? So what you can see here, it's easy math. What you can see here is if you plot this RP minus RF on the vertical axis and RM minus RF on the horizontal axis, you will get a straight line, and this line will have a slope of 0.6, right? So you will get a line like this with the slope of 0.6. So this is the line you can have if the manager does not time the market. It will be a straight line. Now think about this. What will happen if the manager can correctly time the market? Well, the line will be like this. Right? It will be a curved line. So why this means the manager can correctly time the market? Well, the reason is because at this point, we have a smaller slope. This means the manager is only allocating a smaller amount of money into this market portfolio. At this point, we have a larger slope. So this means the manager is allocating a larger fraction of money into the market. This is market timing, right? Because you can see that if the excess return is 10%, the manager is allocating more money compared with when the market excess return was 5%. This precisely says the manager can time the market. That is, if the market increases more, the manager is successfully putting more money into the market, right? So you can see that the shape of this curve, right, when you're drawing the excess return of the portfolio against the excess return of the market, will tell you whether this manager is timing the market or not, right? So you can see that this is a pretty smart and beautiful way to understand manager's ability to time the market. Okay, mathematically, this basically means that, okay, I should say this is definitely optional. Because again, this requires this requires linear regression. So how do you find out this line, right? Well, obviously a easy way would be you will draw these points, right? You will draw these pairs of returns. However, econometrically, we wanted to find out this line. So how do you find out this line? Well, you could use linear regression. And what you do is you will regress a equation like this. So this is the excess return of portfolio P, and this is the excess return of the market index. And A, B, C are just numbers, right? These are just the numbers you can find out using linear regression. And then this is called regression residual, right? So if you're doing this regression, then your key interested variable is this C here. So if this C is positive, then it means that the curve will look like this, right? This is basically very simple math, because if you have the C, which is positive, and if you draw this RP minus RF against RM minus RF, then the curve gonna be look like this, right? And then financial economists, they use this equation to estimate this C for a number of mutual funds. And then they find out there is very little evidence of market timing ability. So essentially it means that most of the time, if you look at fund managers' performance, you will just get a line like this. That is, this guy could not actually correctly time the market, or this guy does not time the market, or this fund manager does not have the ability to time the market. Okay, I will stop. Time is running out.